Hello, friend. Tonight we meet a traveler, quiet, distant, real. Astronomers have found a new object moving through our sky, and it is not from here. It is called 3I, Atlas, a visitor from another star. In all of human history, only 2 such wanderers have been confirmed. 2 brief crossings, 2 soft footnotes in the night. Now a third arrives, and we have time to watch, time to breathe, time to learn what it is made of, how long it has wandered, and what stories it carries from a world we will never touch. Let your shoulders loosen. Let the day fall behind you. Imagine a small light, almost lost among the stars, drifting with patient purpose. It does not loop around our Sunday. It comes, it passes, it goes. Yet while it is here, we can listen. We can trace its path, read its chemistry, and feel the quiet bridge it builds between our home and the deep between the stars. This is not an alarm. This is a gift, a gentle moment of connection across a vast sea. Tonight, we will follow it softly, step by step, with curiosity in one hand and calm in the other. Close your eyes if you like. Keep your heart open. You are safe. You are warm. You are welcome here with AtlasExplore, as we begin our slow journey with the newest visitor from the stars. In the quiet hours of early July 2025, while most of the world slept beneath familiar skies, a small cluster of telescopes in Hawaii continued their patient vigil. Night after night, the Atlas Surveyor network, designed not to seek beauty but to guard against danger, swept across the heavens, searching for anything that moved too quickly, anything that might one day drift too close to Earth. Among millions of fixed points of light, a single pixel began to shift. Barely visible, almost nothing at all. Yet within that subtle motion, a story began. The computers noticed it first. A dot that didn't behave like a star or galaxy. Something closer, smaller, and moving with quiet determination. At first, the data looked ordinary. A faint speck, perhaps another small asteroid or a wandering comet, one of countless visitors looping gently around the Sunday. But the numbers refused to fit. Its motion curved strangely, its speed slightly too high, its path too wide. When astronomers compared the images, frame by frame, the truth emerged. This was not an object bound to the sun's pull. It was passing through, free and untethered, like a leaf carried on a cosmic wind, a messenger from somewhere beyond. It's a gentle irony that Atlas, a system built to warn of danger, instead discovered a gift, a quiet, harmless traveler, offering knowledge instead of threat. In the grand silence of the sky, the instruments designed for defense had stumbled upon wonder. That night was not extraordinary. No alarms, no bursts of light. Just a routine sequence of observations, recorded and filed like thousands before it. Yet, in those unassuming hours, history quietly shifted. The faint point of light moved against a crowded backdrop near the heart of the Milky Way, where countless stars shimmer and overlap like grains of sand. Detecting motion there is like noticing a whisper in a storm. But the whisper persisted. Software flagged it, and soon the data was shared with astronomers around the world. They examined it carefully, tracing its coordinates, recalculating its path. Slowly, certainty replaced curiosity. The object was given a temporary name, C-2025, P1, a code for a comet not yet understood. Then, as the numbers deepened, the pattern became undeniable. Its orbit was not closed. It would not return. The path was open, hyperbolic, a graceful curve that would sweep past the sun once and vanish into the dark again. It was a visitor from the stars, not a child of our Sunday. And so its name changed. 3I 2025, P1, Atlas III, confirmed interstellar object in all of recorded human history. Think of that. Among the infinity of space, Only 3 such travelers have ever been seen. The first startled us, the second confirmed the possibility, and now the third arrives quietly, offering time to watch and listen. A small point of light, drifting through the crowded tapestry of the galaxy, captured not by chance, but by patience. It reminds us that even in the endless motion of the cosmos, miracles do not always shout. Sometimes they appear as nothing more than a trembling pixel on a scientist's screen, whispering across the void, "I am not from here." To call something interstellar is to admit that it was born between the stars, shaped not by the gravity of our sun, but by another light far away. Most comets we know are children of the solar system, frozen wanderers that spend their lives looping faithfully around the Sunday. They are part of our family icy fragments that left their cradle billions of years ago yet still return, again and again, tracing the same luminous arcs across the sky. Interstellar bodies, however, are different. They are free. Their paths do not curve back home. They pass once and continue into the dark, never to return. They belong to no single star, no familiar orbit. They are citizens of the galaxy itself, crossing the invisible borders between stellar neighborhoods with calm indifference to where they came from or where they go next. The word interstellar carries a quiet beauty. It suggests distance and loneliness, yet also connection, a reminder that even the emptiness between suns is not truly empty. Within that immense ocean, fragments of long-forgotten worlds drift like messages in bottles, carrying dust and ice from systems that formed and faded before Earth ever cooled. When one of these fragments strays close enough for us to see, we catch a glimpse of another world's story, told not through words but through light and chemistry. In 2017, humanity witnessed its first such visitor. Astronomers named it Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. It appeared suddenly, a long, slender object tumbling through space with no visible tail, reflecting sunlight in strange and shifting ways. It was so unfamiliar that scientists struggled to describe it, part asteroid, part mystery, perhaps even an ancient shard from a planet that once was. Its visit was brief, leaving more questions than answers, but it proved that interstellar travelers are real. Only 2 years later came another, 2I, Borisov. This one was brighter, surrounded by a glowing coma and trailing a gentle tail of gas and dust. It looked like a classic comet, familiar and yet profoundly foreign. In its spectrum, astronomers found clues of ices and molecules different from those found in our own comets, hints of a chemistry shaped under another star. Borisov confirmed what Oumuamua had only suggested, that our galaxy is alive with motion, and fragments of faraway systems pass among us more often than we ever imagined. Now, with the arrival of 3I, Atlas, a third example completes the pattern. Each visitor has carried its own personality, one silent and solid, one bright and traditional, and now one that blends both qualities with something new. Atlas behaves like a comet, releasing vapor and dust as sunlight warms its surface, yet its path through space reveals that it is not bound to the sun's gravity. It is the third chapter in an unfolding story of discovery, proof that there is no single kind of interstellar wanderer, but many a spectrum of shapes, compositions, and histories drifting through the galaxy. With every new example, our understanding deepens, and the cosmic mosaic grows more intricate and alive. When news of Atlas spread, it did not roar through headlines or stir public alarm. It moved quietly, like the comet itself, carried by whispers among observatories, data networks, and night shift astronomers who understood the rarity of what had appeared. Around the globe, telescopes turned in unison, aligning their domes toward the faint point of light. In Chile, in Hawaii, in Spain and South Africa, lenses and mirrors caught its glow. Across time zones and continents, humans united for a single purpose: to watch, to measure, and to listen. The world did not stop for this event. Yet, in small circles of light scattered across mountaintops. A kind of collective breath was held. Scientists knew that every photon gathered, every spectrum recorded, was a treasure from another world. To them, Atlas was not a curiosity, it was a sample, a physical memory of a distant planetary system, a frozen archive from another sun's creation. In a sense, each interstellar object is a messenger carrying the fingerprints of alien chemistry, the story of how matter forms, cools, and changes across the vastness of the galaxy. Some astronomers described it as receiving a parcel from the universe, wrapped in silence and delivered without a return address. The only condition is time. The package can be opened only while it passes by. When it leaves, it takes its secrets with it. That is why every observation matters, why teams across the world work with quiet urgency. There is no second chance with a traveler like this. And so, beneath the calm rhythm of routine observation, there was an undercurrent of wonder. The faint speck that began as a detection algorithm's alert had become a global pursuit, a thread of cooperation stretching across oceans and night skies. What began as a pixel had turned into a story, one that will unfold through chemistry, mathematics, and imagination. For now, Atlas drifts through our shared sky, a reminder that even among the cold distances between stars, there are bridges. Each one shines for only a moment, but within that moment lies the promise of discovery, the quiet transformation of a single dot of light into one of the greatest cosmic encounters of our time. The search began not with excitement, but with patience, the kind of quiet persistence that astronomy demands. The object that would later be known as 3I Atlas was faint beyond imagination, a whisper of light hidden in one of the most crowded regions of the Milky Way. There, near the galactic center, the sky is a maze of brilliance. Thousands of stars overlap and shimmer like grains of sand lit by an eternal sunrise. Among that glow, finding a single moving dot is like noticing the drift of a single ember in a bonfire. Yet, within that ocean of starlight, something shifted, slowly, repeatedly. Against the still background of the cosmos, a point of light refused to stay still. Astronomers knew what that meant. Movement is the language of change in the sky, and when the pattern repeated across exposures, the first suspicions grew stronger. The algorithms confirmed it, and human eyes followed frame by frame, hour by hour. It was not a reflection or a glitch. It was real. But to understand what it was, they would need sharper vision than the Atlas survey could offer. That call for clarity was answered from the southern hemisphere, where one of the world's great observatories waits above the clouds. The Gemini South Telescope, perched high in the Chilean Andes, was among the first to respond. Its wide mirrors drank in the light from that faint wanderer, focusing it into a point sharp enough to separate from the busy backdrop of the Milky Way. The signal strengthened. The object was not a ghost or a sensor artifact. It was a body, small, moving, and measurable. Each night brought new frames, new data, and with them, new questions. The light curve, the gentle rise and fall of brightness over time, suggested something dynamic, something alive in the frozen sense of the word. As sunlight touched its surface, it seemed to change, brightening slightly, fading again. Perhaps, some thought, this was the first stir of outgassing the breath of a comet, awakening as it approached the Sunday. Soon after, the Hubble Space Telescope joined the search from orbit. Suspended above the shimmer of Earth's atmosphere, Hubble's gaze is unwavering, pure. It sees what ground-based telescopes cannot. The subtle haze around a nucleus, the faintest trace of structure in the light. When Hubble turned its instruments toward 3I Atlas, the images revealed something unmistakable. A thin veil of gas spreading outward, faint but undeniable. The object was developing a coma, a diffuse halo of vapor and dust illuminated by sunlight. And then, not long after, came the tail. It began as a shimmer, a gradient extending away from the sun's direction, forming the soft line that every astronomer knows by heart. The appearance of a tail is the signature of transformation. It meant that the ice within the object was turning directly into gas, releasing particles that caught the light and scattered it into the darkness. In that moment, 3I Atlas became more than a distant speck. It became a comet, alive in the language of astronomy, active and evolving. For many, this was the moment the discovery turned from numbers into awe. Watching the first images of the tail, scientists felt a sense of recognition. This was something they could understand, a familiar phenomenon behaving as expected, but with one breathtaking difference. It did not belong to us. This was the first interstellar comet that humanity could truly study in detail while it was still active. Comparisons began immediately. The first interstellar object, Oumuamua, had offered no such clarity. It was silent and dry, reflecting light in ways that defied easy explanation, leaving more mystery than knowledge in its wake. Some saw it as an asteroid, others speculated wildly, but it left no tail, no coma, no chemistry, to measure only questions. The second, Borisov, had been a revelation. Bright, unmistakably cometary, it carried a sweeping tail and a clear signature of volatile ice. But Borisov had raced past too quickly, discovered only weeks before its closest approach. Astronomers had barely enough time to aim their instruments before it began to fade. 3I Atlas changed that rhythm entirely. For the first time, a visitor from another star had been found early enough for humanity to prepare. The difference was profound. With months instead of days, scientists could coordinate telescopes across the world, align their plans, and capture its journey in full detail. Every stage of its approach could be watched: the awakening of its ices, the growth of its tail, the shift in its orbit as solar radiation shaped its path. It was, in many ways, the first true interstellar laboratory ever to drift through our solar system. The more astronomers looked, the more the comet revealed itself to be both alien and familiar. Like Borisov, it released vapor and dust, forming a gentle plume that stretched across space. But unlike its predecessor, its activity was steady, no violent outbursts, no sudden flares. It behaved almost serenely, as if it had been waiting for eons to perform this dance beneath our sunday. To the scientists watching, it seemed composed, balanced, a wanderer comfortable in its temporary warmth. This stability allowed instruments to take their time. Observations from Gemini South tracked the changes in brightness, mapping the flow of dust as sunlight sculpted it. Spectrographs began teasing apart the light reflected from the coma, splitting it into colors that carried chemical secrets. Meanwhile, Hubble's images captured the slow unfolding of the tail, revealing its direction and texture in exquisite detail. Each observation was like a brushstroke on a cosmic canvas, building the portrait of a visitor from another world. In laboratories and observatories around the planet, the atmosphere was one of focused calm. Scientists often work in bursts of urgency, but this was different. The object was not rushing past, it was gliding. It gave them time to breathe, to plan, to look again. The data gathered each night layered gently upon the last, forming a quiet accumulation of insight. For students and researchers, it felt almost meditative, a global act of listening to the sky. To understand why this mattered so deeply, one must imagine the odds. Space is vast beyond measure, and the distance between stars is so great that a single grain of interstellar dust may drift for billions of years without ever approaching another system. The chance of a comet-sized object entering our narrow window of observation, close enough to study, is astronomically small. And yet, in the span of less than a decade, 3 such wanderers have arrived. It is as if the galaxy has begun to whisper to us, offering fragments of its long and silent story. As images accumulated, 3I Atlas revealed more layers of beauty. Its coma glowed with a soft blue-white hue, the color of sunlight scattered by vaporized ice. The tail, faint but graceful, stretched like a breath across space. At times, through long exposures, it appeared almost alive, a flowing thread of dust tracing invisible currents of solar wind. For amateurs watching from home, these images were dreamlike. For professionals, they were proof. The comet's behavior matched the laws of physics perfectly, yet still managed to stir a sense of wonder that no equation could capture. The realization that this shimmering traveler had formed around another star perhaps before the Earth itself existed gave the discovery a kind of quiet gravity. Every atom of ice within its surface was ancient, unaltered since the dawn of some other solar system. As it released that material into space, our instruments caught it, turning light into knowledge. In that vapor, humanity was reading the molecular handwriting of a distant sun. Night by night, the collaboration grew. Observatories handed the baton from one hemisphere to another, tracking the comet's path continuously as Earth turned. The shared effort was an act of unity across nations and languages, all focused on a faint moving point that connected them through purpose and wonder. When the final data from Hubble confirmed the structure of the coma and tail, it was no longer a matter of debate. 3I Atlas was the third interstellar object in recorded history, and the most accessible one of all. Scientists described it as both a mirror and a bridge. A mirror because in studying it, we see the reflection of our own origins: frozen water, dust, and carbon, the ingredients that once built our world. A bridge because through it, we touch another star's story, understanding that our solar system is not isolated, but part of a greater continuum of creation. In the months that followed, papers would be written, spectra analyzed, and data archived. But for those who were there at the beginning, the night watchers, the patient analysts, the ones who saw the faint light first flicker into recognition, what remained was not just science, but memory. The memory of a small point of light that grew into a comet, the memory of a planet united in quiet observation, and the memory of how, even in the vastness of space, something small and fragile could remind us how connected we truly are. 3I Atlas would continue its journey, its path bending around the sun before it vanished again into the dark. But for a brief and luminous season, humanity had a front-row seat to the story of a wanderer from another star. And in that shared gaze between mirrors, domes, and distant observatories, the line between the familiar and the infinite blurred beautifully. We were not simply observing a comet. We were witnessing a reunion of worlds separated by light years. And for the first time, we had the patience, the instruments, and the awareness to truly see it. The path of 3I Atlas was unlike the quiet, circular orbits that keep most comets tethered to the sundial. When astronomers traced its motion through the sky, the numbers told a story written not in light, but in geometry, a story of escape. Its trajectory formed a wide, open curve, what physicists call a hyperbolic orbit. Such an orbit is proof beyond question that the comet did not begin here. It was not born from the icy reservoirs beyond Neptune, nor from the faint halo of the Oort cloud that surrounds our solar system. A hyperbola means freedom. It means that gravity can only bend its path, never capture it. 3I Atlas would come close once, curve around the sun, and then return forever to the interstellar dark. To the scientists studying it, this orbit was both thrilling and melancholy. Thrilling because it was absolute confirmation that they were witnessing a true traveler from another star. Melancholy because it meant the encounter would be brief, a single crossing written across the sky. Gravity would pull gently on it as it passed, slowing its speed just a little but never enough to hold it. Even as the sun's warmth awakened its frozen gases and painted its tail with light, its momentum carried it outward again, away from the family of planets, back into the vast and silent gulf between suns. The shape of that orbit allowed astronomers to predict something extraordinary. On the 30th of October, 2025, the comet would reach perihelion, its closest point to the sundial. In that moment, it would shine at its brightest, its activity rising to a peak as trapped ices within the nucleus boiled into vapor and streamed away in long ribbons of dust. Perihelion is a comet's heartbeat, the instant when it is most alive. For 3I Atlas, it would also be the briefest window of understanding, the only time when its chemistry, motion, and light could be studied in perfect clarity before it slipped away again into cold space. Across observatories on Earth, that date was circled months in advance. Teams planned their schedules with meticulous care, calculating exposure times, calibrating instruments, and coordinating telescope arrays so that not a single moment would be wasted. Orbiting spacecraft were prepared as well. Both the Hubble Space Telescope and the James Webb Space Telescope were assigned observation windows to capture the interstellar visitor at its most radiant. Even probes circling Mars might join the watch, since the comet's path would bring it within observational range of the red planet's orbit. The idea that robotic eyes orbiting another world could look outward and see this same wanderer was profoundly moving, one world observing another's guest, both tiny points of awareness under a single star. Despite its luminous display, the comet posed no danger to Earth. At its nearest, it would remain many millions of kilometers away, far beyond the Moon's distance, closer to the outer paths traced by Mars. Yet in the scale of astronomy, that is still a near encounter. Its proximity meant that even modest telescopes could glimpse it under dark skies, turning an event of scientific precision into one of quiet public wonder. Amateur astronomers would have the chance to photograph a visitor from another solar system, each long exposure revealing a soft streak of motion against the stillness of the stars. For a brief season, anyone looking upward with patience and curiosity might share in the story that began billions of years ago in another corner of the galaxy. Speed, however, was the defining feature of this traveler. Even as it slowed near the sun, 3I Atlas moved at tens of kilometers every second, fast enough to cross the entire span between Earth and the Moon in only a few hours. That velocity was far beyond anything our planets could achieve, far beyond the pull of the sun's gravity to restrain. It was the speed of exile, the signature of something cast out long ago by the gravitational chaos of another star system. For astronomers, measuring that speed was like hearing the echo of its birth. Only an object that had once orbited a distant sun and been flung outward by the dance of massive planets could move so swiftly through our sky. Tracking such motion was both a challenge and a meditation. Night by night, its position shifted more quickly than most telescopes could easily follow. To keep pace, observatories synchronized across hemispheres, handing observations from west to east as Earth turned beneath the stars. Each data point refined the orbital model, each correction narrowing the uncertainty until the comet's path through space was known with exquisite precision. The act of prediction became a quiet art, using the mathematics of gravity to draw the curve of a life that began light years away. As it swept around the sun, the comet's brightness would swell, then fade. Gases once frozen for eons would erupt briefly into space, forming the delicate veil of the coma and the streaming tail that pointed always away from the Sunday. After perihelion, the process would reverse. The heat would lessen, the jets would quiet, and the glow would thin until only the bare nucleus remained, a dark stone drifting outward into eternity. In that retreat, scientists found a strange kind of poetry. The comet's journey mirrored the rhythm of breath, an inhale of light as it approached, an exhale of dust as it departed, and then a long stillness as it returned to the dark. For those studying its motion, the numbers carried emotion. The eccentricity of its orbit greater than 1, the mathematical mark of escape, meant it would never again cross our sky. Once it passed beyond the sun's reach, no future generation would see it. Its velocity would carry it into interstellar night, perhaps to drift for another billion years before passing through the domain of a different star, perhaps to be noticed by beings as curious as we are. The thought lent the calculations a quiet reverence. Every observation, every line of code, Every image captured from Earth or Mars or orbiting telescopes was a farewell. Yet, within that farewell was triumph. For the first time in history, humanity was able to map the full arc of an interstellar comet's path from discovery to departure. We knew where it came from beyond our sun's gravity and where it would go. We understood its speed, its temperature, its chemistry, its luminous breath. We could trace, with almost tender precision, the curve of its freedom. That knowledge was a bridge between imagination and proof. A reminder that the spaces between stars are not empty, but threaded with motion, carrying messengers like Atlas from one world to the next. As October approached, anticipation grew. Simulations ran endlessly, predicting the comet's glow and the direction of its tail. In digital models, it curved gracefully through the inner solar system, its path intersecting the orbits of Mercury and Mars, its vapor trailing like silk. On the day of perihelion, as sunlight poured across its surface, telescopes around Earth would watch in silence, waiting for the comet to flare. Some scientists expected a modest brightening. Others dreamed of a display visible even to the naked eye. Whatever the outcome, the meaning would remain the same. A fragment of another star system was passing within our sight, gifting us a few weeks of light before continuing its endless journey. In this way, the orbit of 3I Atlas became more than a set of coordinates. It became a story of motion, of gravity, and of time. Its open curve was a sentence written across the sky, beginning in another world and ending in ours. The sun would touch it once, gently, and then release it. And as it vanished into the distance, carrying dust that had never before felt our light, the world would be left with a memory, a reminder that even in the boundless stillness of space, every traveler leaves a trace, and every orbit, no matter how brief, is a chapter in the grand narrative of the cosmos. When sunlight began to reach the frozen surface of 3I Atlas, the quiet traveler awoke. For countless ages it had drifted through the interstellar dark, untouched by warmth, its body locked in stillness colder than any winter on Earth. Then, as it crossed the outer threshold of the solar system, the light of our sun, faint at first, then stronger, spilled across its surface. That light carried heat, and heat carried change. Molecules of ancient ice, trapped since the birth of another star, began to tremble and break apart. Solid frost turned directly into vapor in a process called sublimation, and in that transformation, the comet found its voice. It exhaled. From vents and fractures across its nucleus, jets of gas escaped into the surrounding vacuum, dragging tiny grains of dust along with them. The gases expanded outward, forming a pale, luminous envelope that wrapped the nucleus like a thin atmosphere. Astronomers call this shimmering cloud. The coma, a fragile sphere of vapor that glows softly as it reflects sunlight. Around the heart of the comet, the coma became its living aura, constantly renewed as more material evaporated, constantly fading as solar radiation pushed it away. This awakening was not violent. It was more like the slow blooming of a flower after a long sleep. Day by day, telescopes recorded the growing halo around the nucleus, its brightness rising gently as the comet moved inward. Through the instruments of Gemini South and the Hubble Space Telescope, astronomers could see the texture of the light changing. What had once been a single, sharp point of brilliance now spread into a haze, a visible sign that the comet was alive and breathing in the language of physics. As the gases expanded farther from the nucleus, they met the invisible breath of the sun, a constant stream of charged particles known as the solar wind. This wind flowed outward through the solar system, carrying magnetic fields and energy, shaping every comet that crossed its path. The moment it touched Atlas, it sculpted the escaping material into a long, delicate structure that pointed away from the sunday. This was the tail, the most poetic and recognizable symbol of a comet's journey. Two kinds of light began to emerge from this transformation. The dust tail, made of microscopic grains lifted from the surface, shone with a warm, golden-white glow. These tiny particles reflected sunlight directly, like countless mirrors suspended in space. They trailed behind the comet's path in a gentle curve, tracing the motion of its orbit. Alongside it, a second structure appeared, the ion tail, composed of gases stripped of electrons by the sun's radiation. This one glowed faintly blue, a result of ionized carbon and other molecules fluorescing under ultraviolet light. The blue tail did not follow the curve of motion. Instead, it stretched straight outward, always pointing directly away from the sun like a compass needle aligned with the solar wind. To the naked eye, the tails might appear as one blended stream of light. But through spectroscopes, scientists could separate them into their elemental voices. By splitting the light into its component colors, they revealed the chemistry of the coma: traces of water vapor, carbon monoxide, carbon dioxide, and smaller quantities of ammonia and organic molecules. Each line in the spectrum was a fingerprint, a clue to the materials that had formed around a distant star billions of years ago. The presence of carbon dioxide in particular stood out. It was unusually abundant, suggesting that the comet's birthplace had been colder than the region where our own solar system's comets formed. In this way, spectroscopy became more than observation. It became a conversation across time and space. The analysis also extended to dust. By studying how sunlight scattered through the coma, astronomers estimated the size of the particles drifting away from the nucleus. Some were as fine as smoke, others as coarse as sand. Their composition reflected the building blocks of rocky worlds, silicates, carbon, and ices that once orbited another star. Each grain carried a history older than Earth, preserved through unthinkable distances and years. To watch them scatter in our sun's light was to see the distant past illuminated in the present. But with activity came uncertainty. Comets are fragile things, held together by little more than frozen gases and dust. As heat increases, their surfaces can crack, their cores split apart, and sometimes they disintegrate entirely in a sudden flash. The question lingered among astronomers: would 3I Atlas survive its encounter with the sun? Or would it shatter under the pressure of its own awakening? Night after night, observations continued, and a pattern emerged. The brightness rose smoothly, with no violent spikes or sudden fading. The jets of gas, though active, remained stable, their orientation shifting predictably as the comet rotated. There were no signs of continued to soften. Knowledge was no longer a privilege, but a shared endeavor, and the comet became a symbol of that shift. When historians of science look back on the passage of 3I Atlas, they may see not only an interstellar discovery, but a portrait of an era, a moment when humanity learned to work together at planetary scale. The comet's brief journey through our skies happened to coincide with the maturity of a global digital infrastructure, capable of uniting thousands of observers in real time. It demonstrated that the age of isolated discoveries is ending. From now on, the universe will be explored by networks of minds, connected across continents, listening together for the faint music of the stars. And so the pursuit of Atlas became something larger than astronomy. It became a meditation on cooperation, a demonstration that the same principles guiding comets, gravity, resonance, connection, also guide us. The minor planet center's constant pulse, Hubble's unwavering eye, Rubin's rising promise, the student's long nights, the amateur's quiet dedication. All were threads woven into one tapestry of curiosity. The work was not glamorous or fast, but it was harmonious. When the final coordinated campaign concluded and the comet slipped once more into the far distance, there was no single celebration. Instead, there was a shared sense of gratitude. Around the world, those who had followed its passage looked up at the night sky with a new understanding that discovery is a collective act, and that even in an age defined by speed and isolation, we can still pause, coordinate, and listen together. The last datasets were archived, the final reports filed. But the lesson lingered like a soft echo. Science is not solitary. It is a symphony of eyes and instruments, each adding its voice to the great silence, turning one fleeting visitor from another star into a story written by an entire planet. When the instruments had fallen silent and the data streams slowed to a trickle, something lingered in the minds of those who had watched 3I Atlas. It was not a number or a graph, not a measurement of brightness or a curve of orbit, but a feeling. The comet had passed through our sky like a thought, fleeting, luminous, impossible to hold, and even the most analytical hearts found themselves moved by it. In the months of its observation, the world had spoken in the language of chemistry and physics, but behind every calculation there had been awe. When it was finally gone, that awe remained, a soft afterglow that no telescope could record. To step back from the data is to rediscover wonder. The story of Atlas was built from equations, yet what we remember is its light. Through telescopes, its color appeared a fragile, blue-green, the hue of carbon gas glowing when struck by sunlight. It was the same color that flickers in the flame of a candle, the same tint that drifts in the auroras over the polar sky. Around the comet's nucleus, that gentle radiance shimmered against the darkness, a faint mist that seemed almost alive. When the light passed through the tail, it scattered into golds and silvers, strands of dust reflecting the sun, as if the cosmos itself were weaving silk. Each image carried something delicate, something human, an impression of motion so slow that it felt like breathing. If one could have stood beside it, there would have been no sound at all. In the vacuum between worlds, silence reigns complete. The jets of vapor that looked so lively in photographs would have erupted without noise, the dust spreading into space like whispers that cannot be heard. This absence of sound gave its movement a solemn grace. Atlas glided in perfect stillness, as if the universe itself were holding its breath. It was a reminder that not all music is made of vibration. Some melodies are felt only in the mind. Watching the comet drift across the black canvas of the sky, many observers described an odd serenity, the sense that time had slowed, that they were glimpsing the quiet pulse of creation itself. The colors of the coma and tail were more than beauty. They were memory made visible. Every shade corresponded to an element, every glimmer to a process older than the Earth. The blue came from carbon molecules, the pale gold from dust that once formed around an ancient star. Together, they wrote the comet's autobiography in light. Through the eyes of physics, these were spectral emissions and reflected wavelengths. Through the eyes of poetry, they were the handwriting of time, the visible breath of a world that had waited billions of years to be seen. Even those who never looked through a telescope could feel its presence. News reports showed composite images, a faint streak in a field of stars, the tail angled slightly away from the sun, glowing like a thought half remembered. In the cities, where light pollution hid the sky, people imagined it instead a traveler glowing silently beyond their sight. Some said it made them feel small. Others said it made them feel connected. Both were true. To gaze upon something that has crossed between stars is to be reminded that we, too, are made of traveling matter, bound by the same laws of motion and the same desire to shine before fading into the dark. In that silence, scientists found something resembling prayer. The comet's passage was not just data gathering, it was contemplation. Beneath the machinery of measurement lay an emotional core, gratitude for existence, for curiosity, for the ability to notice at all. Astronomy has always carried that double nature, part mathematics, part meditation. To calculate an orbit is to trace the geometry of wonder. Long before telescopes or spectroscopy, humanity looked up at comets with mixed awe and fear. In ancient China, scribes recorded them as broom stars, sweeping away dynasties or heralding new emperors. In Europe, they were swords of heaven, symbols of divine judgment or change. The Babylonians saw them as celestial messengers, the Maya as fiery serpents crossing the sky. Every culture sought meaning in their sudden appearance, interpreting them as signs from gods, spirits, or fate. For most of history, a comet meant disruption, the breaking of the ordinary order of the heavens. Atlas II arrived suddenly, unannounced. But its message was different. It did not foretell disaster. It invited understanding. It carried no omen of war or plague, only the calm promise of knowledge. In that way, it transformed one of humanity's oldest symbols of fear into a modern emblem of curiosity. Once, a comet's light was thought to bring endings. Now, it brought connection. Atlas became, in the language of our age, a good omen of science. Proof that mystery can coexist with meaning without conflict. That transformation says as much about us as it does about the comet. We have learned to replace superstition with wonder, to see beauty where once we saw threat. Yet in a deeper sense, we have not changed at all. The same imagination that once saw divine chariots in the sky now builds telescopes to ride those chariots in thought. Myth and science are not enemies. They are different accents of the same voice, the voice that asks why. Atlas spoke to both at once. Its presence satisfied the intellect while awakening the soul. Many poets wrote of it during its brief stay, describing it as a messenger without words, a spark of eternity, a ghost that remembers the light. In their verses, the comet became a mirror of human life, small, bright, transient, carrying history in its fragile form. One writer called it the universe dreaming of itself. Such language may sound distant from science, yet in spirit it is close. The astrophysicist, too, seeks the dream behind the numbers. Every photon captured by a sensor is a syllable of that dream. Even within laboratories, emotion found its place. Researchers described nights spent alone at their instruments, watching the data scroll across screens, feeling a kinship with the object they measured. They knew that its light had traveled millions of kilometers to reach them, that what they were seeing had already happened hours before. In that delay, they sensed the vastness of time. Science became a form of remembering, of retrieving stories written in radiation. When the spectra revealed unexpected richness, the dance of carbon dioxide, the shimmer of dust, they felt not triumph but tenderness. It was like hearing a long-lost song played once more. Artists joined the chorus. Painters rendered the comet's colors with delicate gradients. Composers wrote slow, drifting pieces that echoed its pace through the sky. In planetariums, digital domes projected its motion, and visitors reclined beneath simulated tails of light, their faces bathed in blue. Through art, the comet re-entered the realm of feeling it had occupied in ancient times, yet now it brought insight rather than fear. The boundary between fact and imagination dissolved, replaced by continuity. To understand a comet like Atlas is to accept that knowledge and wonder are not opposites. Science measures, poetry listens. Both are ways of attending to the world. The equations that describe its trajectory are themselves a kind of verse rhythm, pattern, repetition, variation. The spectroscopy of its gases reads like a stanza, written in the alphabet of atoms. And the silence of space, which no human ear can hear, is its meter. Slow, patient, infinite. In this light, science becomes not a cold discipline, but a celebration of connection. Every observation of Atlas was an act of empathy toward the universe, an attempt to understand rather than to command. The same empathy that once gave birth to myth now drives exploration. We name comets not to claim them, but to greet them. In naming 3i Atlas, we acknowledged both our instruments and our inheritance, a blend of intellect and awe stretching back through millennia. Somewhere within this blend lies the future of human thought. The comet taught us that meaning is not confined to categories. Numbers can sing, photons can tell stories. A single object moving through the sky can unite physicists and poets, students and dreamers across continents. It showed that progress in knowledge need not silence imagination. It can refine it. As the comet faded, so did the distinctions between disciplines, leaving only shared reverence for the cosmos. If one were to translate the passage of Atlas into pure metaphor, it would be this: the universe remembering itself through us. We, who evolved from stardust, now study the dust returning from other stars. We are both the observers and the observed, the dreamers and the dream. The comet's tail, shining across the night, is a reminder that every particle of matter has traveled, transformed, and returned in new form. In watching it, we witnessed not something foreign, but a reflection of our own continuity. When Atlas finally disappeared beyond telescopic reach, its departure felt less like loss and more like closure. The data would remain, but so would the feeling, that quiet sense of belonging to a story too vast for words. The comet had entered our sky as a question and left as an answer: that science and poetry are simply two ways of loving the same truth. One counts, the other feels, and together they remind us that the cosmos is both measurable and miraculous. Long after, when students study its spectra or artists paint its trail, they will be continuing that conversation. Each equation, each brushstroke will echo the same thought: that the universe does not ask us to choose between knowledge and wonder. It asks us to hold both, gently, in balance, as Atlas did, glowing softly beneath the sun, carrying within its blue light the harmony of fact and feeling, the merging of science and song. And perhaps, in some future century, when another interstellar comet drifts into view, humanity will greet it differently, but with the same heartbeat. Instruments will hum, poets will write. Across disciplines, generations, and languages, the story will continue the ancient human ritual of turning the unknown into beauty. That will be the legacy of Atlas, not only a comet from beyond the stars, but a reminder that curiosity itself is our brightest tale, our enduring light, stretching forever through the darkness, illuminating both reason and wonder with a single, timeless glow. In the quiet that followed its departure, when the comet's light had faded beyond the reach of telescopes, what remained was not absence, but reflection. 3I Atlas had crossed our sky like a slow, wordless teacher, leaving lessons suspended in its trail of dust and light. They were not lessons written in textbooks or equations, but inscribed softly into the minds of those who had watched with patience. The comet did not lecture. It simply existed, and through that existence, it taught. The first lesson was patience. Atlas revealed itself not in a moment of drama, but through long nights of careful watching. The faint dot that began its story could have been dismissed as noise, a random flicker in the crowded field of stars. Yet someone noticed, then someone else confirmed. Slowly, through repetition and care, a pattern emerged. It took weeks of verification before that dim pixel became a visitor from another world. The discovery reminded humanity that wonder often hides behind monotony, that the universe reveals its secrets only to those who linger long enough to listen. In a world addicted to immediacy, Atlas whispered a counter-truth. The cosmos does not hurry. Stars form over millions of years, comets drift for billions, and insight comes in its own time. Science, like the sky itself, moves in patient rhythms. The second lesson was discipline. To transform that tiny dot into knowledge required not inspiration alone, but structure repeated, observation, calibration, and data refined with almost monastic devotion. Each night, telescopes turned toward the same coordinates. Each image was analyzed pixel by pixel, each measurement compared against previous ones. It was tedious, methodical, and, at times, uncertain. Yet within that discipline lay a kind of grace. The astronomers' diligence became an act of reverence, a nightly ritual that connected them to something greater than themselves. The comet's motion across the stars was slow, almost imperceptible, but through disciplined persistence, it was revealed as truth. Science, at its best, is not a pursuit of perfection but a practice of care, an acknowledgement that every detail, no matter how small, carries meaning. The third lesson was adaptability. The universe does not follow human schedules, and discovery often arrives uninvited. When Atlas appeared, observatories were focused on other targets, projects long planned and funded. Yet within hours, priorities shifted. Instruments were recalibrated, proposals rewritten, collaborations formed overnight. The ability to change direction without losing purpose became its own kind of artistry. In that swift coordination, telescopes handing off observations from hemisphere to hemisphere, we saw how science thrives, not on certainty, but on flexibility. Atlas reminded its observers that readiness for surprise is as vital as preparation. In the same way that the comet had been cast into freedom by a sudden gravitational encounter, human discovery often advances through moments of disruption, when curiosity is nimble enough to seize the unexpected. Then came the lesson of restraint. When the first interstellar visitor, Oumuamua, arrived in 2017, speculation ran wild theories of alien craft, hollow ships, and strange technologies filled headlines. The frenzy overshadowed the quiet truth that, even without fantasy, the object was already extraordinary. By the time 3I Atlas appeared, the community had learned. There was no hysteria, no sensational claims. Observers spoke calmly, measuredly, letting the evidence lead. They understood that exaggeration is not the friend of wonder. The universe, in its true form, is already miraculous. A comet traveling from another star system needs no embellishment to inspire awe. Its story stands on its own, luminous and sufficient. Atlas thus became a model of how maturity in science mirrors maturity in spirit. The ability to marvel without distorting, to celebrate without claiming. The fifth lesson, perhaps the most beautiful, was the art of translation turning data into poetry. Each graph and spectrum, each row of numbers, was also a story. In the shape of its orbit lay the tale of exile. In the ratios of its gases, the memory of another sun. In the faint fluctuations of its brightness, the rhythm of a slow cosmic heartbeat, scientists, knowingly or not, became storytellers, giving voice to the inanimate. The comet, in turn, became a kind of language, a sentence written across space that only collaboration could complete. Every observation was a word, every analysis a line of verse. To study Atlas was to read poetry in the syntax of light, to realize that comprehension and creation are not opposites, but partners in the same dance of curiosity. Together, these lessons formed a kind of philosophy, a quiet guide for the next age of discovery. Patience, discipline, adaptability, restraint, and imagination. 5 pillars not only of science, but of being human in an immense and unpredictable cosmos. The comet had offered them freely, asking nothing in return. In its passing, it seemed to whisper that understanding is not only about answers, but about the posture of mind we bring to the unknown. Looking back across time, astronomers saw how these lessons threaded through the lineage of all interstellar visitors. Oumuamua, first of the trio, had taught humility, that the cosmos can still surprise us with forms that defy categories. It was dry, elongated, and mysterious, leaving questions unresolved. 2I Borisov, discovered 2 years later, brought familiarity. A classic comet, active and radiant, proving that the material of other systems can resemble our own. And now 3I Atlas, with its steady brightness and rich chemistry, had united those extremes, familiar yet alien, predictable yet unique. Together, they formed a trilogy of revelation. 3 chapters of the same epic, each expanding our sense of what it means to live in a galactic community. From these 3 wanderers, humanity began to trace the outlines of a new kind of map, not of land or ocean, but of possibility. For the first time, scientists could begin to imagine an interstellar traffic pattern, a network of objects drifting through the Milky Way, linking distant systems through invisible threads of motion. Each comet, asteroid, or fragment that passes through our neighborhood is part of this grand circulation, a slow exchange of material across the galaxy. Through them, the stars converse. They trade dust and ice, share chemistry, and carry echoes of one another's histories. It is as if the Milky Way itself is breathing, inhaling, and exhaling fragments of its own story, one visitor at a time. The mapping of this cosmic network has already begun by studying the velocities and trajectories of interstellar objects. Astronomers can infer their regions of origin, the thick disk, the spiral arms, the stellar nurseries. Future instruments like the Vera Rubin Observatory will add to this cartography, detecting visitors long before they arrive. One day, perhaps, spacecraft may even intercept them, sampling the ancient matter they carry. Each encounter will add a new coordinate to the growing chart of interstellar exchange. A galactic atlas of connections, fittingly named after the very system that discovered the comet. In this sense, 3i Atlas is not only a traveler but a cornerstone, marking the point where human perception began to grasp the scale of the Milky Way as a living, circulating whole. And yet, beyond the charts and coordinates, there remains the simple truth that what binds all these discoveries together is wonder. For all our technology and theory, we are still, at heart, beings who look up. The comet's long arc across the sky reminded us that knowledge does not end curiosity. It deepens it. Every answer widens the horizon of the next question. The scientists who studied Atlas will move on to other objects, other data, but some quiet part of them will always remember the feeling of standing under that shared sky, knowing that for a brief time they were watching a messenger from another sun. Perhaps that is the final lesson of Atlas, that science is not separate from the human spirit. It is the spirit, extended outward, disciplined by evidence but driven by wonder. The comet taught us to measure carefully, but also to feel deeply. To reason with precision, but also to dream without shame. Its faint light bridged centuries of human thought, from ancient myths of flaming omens to modern maps of galactic motion. In its passing, it gathered every era of imagination into one continuous thread. When future generations look back on this time, they may see Atlas not just as a comet, but as a milestone in consciousness, the moment when we realize that we are not only inhabitants of one solar system, but participants in a vast cosmic dialogue. The trilogy of Oumuamua, Borisov, and Atlas will read like the opening pages of a new chapter in astronomy, a preface to the era of interstellar awareness. From 3 small bodies, we began to sense the true breadth of our galaxy, a place not of isolation, but of exchange, not of solitude, but of shared motion. In this way, the lessons of Atlas expand beyond astronomy. Patience becomes mindfulness, discipline becomes devotion, adaptability becomes resilience, restraint becomes wisdom, imagination becomes love. Each is a way of seeing, of recognizing that to understand the universe is to participate in it. Science, philosophy, and art converge in that realization. The comet, in its slow, silent arc, revealed no grand secret, only a mirror. What we saw reflected there was ourselves, small, temporary, yet luminous with curiosity. And so, as its memory fades into the archives of data and the pages of literature, 3i Atlas continues to teach. It reminds us that the next discovery may already be drifting toward us, unnoticed, waiting for another patient observer to find meaning in a single shifting pixel. When that moment comes, we will be ready, wiser, humbler, more attuned to the delicate conversation between stars. We will know that the act of watching the sky is also an act of listening, that in every beam of light there is a story, and that in every story there is a lesson worth learning again. For the universe is a classroom without walls, and Atlas was one of its teachers, a traveler who spoke through light instead of language, who passed once through our night to remind us how to see. From it, we learned that discovery is not conquest, but communion, not the claiming of knowledge, but the sharing of wonder. And as we continue to map the dark, tracing the paths of new wanderers to come, we carry its lessons with us. To observe with patience, to think with care, to imagine with courage, and to remember always that even the smallest speck of light can illuminate the infinite. The time always comes when even the brightest wanderer must fade. 3. Atlas, once the quiet centerpiece of our sky, is now receding into the deep black, leaving behind the orbit of the sun and the attentive gaze of our instruments. Its faint blue glow, once caught in the mirrors of Hubble and Webb, has dimmed into the invisible. What remains is silence, the same profound stillness it carried across the galaxy for billions of years before we ever saw it. Soon, even the most powerful telescopes will lose sight of it entirely. Yet in another sense, Atlas will never be gone. Its image now lives within us, written not in the sky, but in memory, in data, in the soft pulse of human understanding. In observatories around the world, the final data logs are already sealed. Numbers that once appeared as live streams of brightness now rest in archives, tagged with dates and coordinates, destined to outlive their discoverers. Every spectrum, every image, every calculation has joined the quiet library of human knowledge. What one astronomer called the shadow atlas left inside the database of civilization. It is a poetic thought that when a comet disappears into darkness, it leaves behind a reflection made not of light, but of meaning. For centuries to come, others will open those digital vaults, reconstructing the comet's orbit, rereading its chemistry, finding new insights hidden in old measurements. Data, too, has its form of immortality. In that legacy lies one of science's purest virtues, continuity. Each generation watches a little further, measures a little finer, and passes the story onward. The study of Atlas is not a closed chapter, but an invitation. A signal flung into the future saying, continue. Perhaps one day, long after its light has faded entirely, a spacecraft launched from Earth will meet another traveler like it face to face. The dream is already forming. Robotic emissaries waiting in orbit, ready to intercept the next interstellar visitor, to sample its dust, to touch the material of another star. The technology is distant but imaginable. What once seemed myth reaching out to a wanderer from beyond now feels like destiny. Atlas opened that door, and there will be others. Astronomers estimate that hundreds, perhaps thousands, of interstellar objects wander unseen through our galaxy at any given time. Most are faint, quiet, anonymous. A few will drift near enough to be caught in the sun's gravity, their icy surfaces awakening for a brief and luminous season. Atlas is only the beginning, one chapter in a vast migration of matter that has been unfolding since the Milky Way's birth. In this sense, every future discovery will be a kind of reunion. Each time we find another, we will remember this one, the comet that taught us how to listen, how to measure, and how to marvel without fear. The emotional legacy of Atlas may be even greater than its scientific one. For in studying this comet, humanity did not just extend its map of space, it expanded its map of feeling. We learned that knowledge and wonder can coexist, that precision does not diminish mystery, it deepens it. Each new observation we make adds not only to the coordinates of our cosmic chart, but to the coordinates of our inner landscape. Curiosity, empathy, and humility are all part of the same navigation. To measure the stars is to measure ourselves. As Atlas departs, it leaves behind a quiet invitation to reflect not only on where it came from, but on what it revealed about us. We are a species that builds mirrors for the heavens, that tracks dust across billions of kilometers, that stays awake at night for a glimpse of something ancient and passing. We chase these wanderers not for conquest, but for communion. Each comet, each star, each distant signal is a chance to remember that we belong to a galaxy alive with exchange, a network of matter, light, and thought. The universe is not a void we explore. It is a conversation we are learning to join. Imagine the comet now, far beyond the planets, gliding through the darkness between stars. Its tail has vanished, its coma frozen again into silence. Sunlight no longer touches it. The only glow now comes from within the faint radioactive warmth of elements, decaying quietly. The same warmth that once guided our instruments. It will travel for uncounted ages, through regions of the galaxy where no human will ever follow. Yet, somewhere deep inside that ancient ice lies the trace of us, the moment when light from our sun awakened it, when telescopes on a small blue world turned toward it with wonder. For the briefest of moments, our stories crossed. Then we parted, each continuing our separate journey through time. What Atlas leaves behind is not emptiness, but presence. It reminds us that connection does not depend on permanence. A traveler may pass once through our sky and still change the way we see the universe forever. The comet's message, if it can be called that, is one of perspective, that beauty can exist without belonging, that meaning can arise without intention. In the vast, indifferent geometry of space, even a fleeting glimmer can hold the weight of eternity. As the mission logs close and the sky returns to its ordinary stillness, the voice of Atlas explore this series. This shared meditation becomes a kind of echo of that light. We speak not to fill the silence, but to honor it. We remember that in every grain of dust there is history, and in every act of looking there is reverence. The stars may be distant, yet their light touches us still. The comet may have been here only briefly, yet in its departure it left behind something vast, a sense of calm, of scale, of belonging to something greater than ourselves. So, farewell, three-eye Atlas traveler from another sun, mirror of time, messenger without a home. You entered our lives quietly, gliding through the fields of stars, and you depart the same way, carrying our wonder with you into the long dark. Your data rests safely in our archives, your image engraved in our minds. Wherever you go, a small part of humanity drifts with you, encoded in the light we shared. And to those who have followed this journey, here listeners, dreamers, wanderers of thought, let the story continue within you. Let your curiosity be its tail, your imagination its orbit, your patience its light. There are countless travelers yet to come, countless mysteries waiting at the edge of our perception. The map of the cosmos is still being drawn, and so is the map of our hearts. Perhaps, one night, another interstellar comet will appear a faint point against the Milky Way, another whisper in the dark, and when it does, may we greet it with the same quiet reverence we gave Atlas, knowing that to look up is to remember where we come from, and to measure the infinite is to feel, once more, profoundly alive. The stars may be far away, but their light still finds us. Atlas passed only once, yet left behind stillness, humility, and awe gifts no less bright than the comet itself. And so, as this journey closes, let your thoughts drift freely with the next wanderers of the galaxy. Let your mind rest in the rhythm of their motion. For the sky is wide, the night is kind, and the universe is always speaking softly, endlessly, to those who choose to listen. Welcome, always, to AtlasExplore. Catastrophic outbursts or fragmentation. Three-eye Atlas was holding together. It seemed to endure the heat with quiet resilience, shedding material steadily but gracefully. Its steadiness became its signature. Unlike the dramatic flares of some comets that briefly blaze and then vanish, Atlas glowed with calm persistence, its tail lengthening each week into an elegant arc. As it approached the sun, the comet's geometry in space created beautiful illusions for those watching from Earth. Because the dust tail curves along the comet's orbit, while the iron tail points directly away from the sun, there were moments when one seemed to cross over the other, forming a subtle V-shape against the black of space. For a few nights near perihelion, photographers captured this delicate intersection, a symbol of two forces at play: the pull of motion and the push of light. At the height of its activity, Atlas's coma expanded to tens of thousands of kilometers, a luminous sphere larger than any planet, yet so diffuse that a spaceship could fly straight through it without harm. The tail stretched millions of kilometers into space, a translucent banner of dust glowing softly against the starfield. And all of it, the gas, the light, the color, was powered by a single source: sunlight. Energy from a star 93 million miles away was enough to awaken this frozen relic and turn it into a living spectacle. For those who observed it, this transformation carried both scientific and emotional weight. Every equation that explained the sublimation of ice also hinted at something more profound: the fragile balance between heat and cold, between stillness and motion. The comet was a reminder that change, even after billions of years, can arrive softly and beautifully. Under the sun's warmth, what had once been inert found new expression. It did not resist its transformation. It surrendered to it, and in doing so, became radiant. Scientists sometimes describe comets as time machines, carrying within them the unaltered materials of their birth. Yet, watching 3I Atlas come alive, one could also see them as mirrors. The sun's light awakened its surface, just as awareness awakens memory. The vapor rising from its crust was not destruction, but revelation. Layer by layer, the comet was unveiling what had been hidden since before our own world formed. Spectroscopic readings continued to flow in from telescopes across the globe. Each wavelength of light offered new information: the density of the coma, the velocity of the escaping gases, the pattern of rotation of the nucleus itself. These details painted a picture of balance, a traveler that had found equilibrium between warmth and endurance. Unlike some comets that fragment under stress, Atlas seemed almost serene. The strength of its structure suggested it was compact, cohesive, perhaps fused by the cold of interstellar space into something sturdier than typical comets of our Sunday. As days passed and the comet neared its closest approach, its behavior remained consistent. The coma glowed steadily. The tail widened into a graceful fan. Observers described it as both familiar and foreign, a creature of known anatomy, yet with a heart that beat to a rhythm beyond our solar system. Its dust and gases responded to sunlight just as ours do, yet their chemistry whispered of another origin, another sun that once shone where ours does now. Through every image and measurement, one truth emerged. 3I Atlas was speaking in a language we understood, but with an accent from another world. It was both kin and stranger. Its light carried the warmth of our sun and the memory of another. It was, in every sense, the embodiment of connection across the void, an emissary reminding us that the laws of nature are universal, even as the stories they tell are endlessly diverse. By the time it reached the peak of its journey, 3I Atlas had shown us what it means to awaken gracefully. Its coma and tail were not signs of chaos, but of harmony, a dialogue between matter and energy, ancient ice and present light. Looking at it through our telescopes was like looking into a reflection of our own beginnings, how heat and light once shaped the cold dust that became the planets, and how even now, across interstellar distances, the same forces continue their gentle work. When astronomers looked at the final composite images of the comet's full form, its glowing coma, its twin tails, its delicate curves, they described it with words rarely used in science. Tranquil, dignified, almost self-aware. It was as though the comet itself was whispering, "I am a comet, but I am not from here." And in that quiet declaration, there was something deeply human, the recognition that to wander does not mean to be lost, and that even those who come from far away can shine briefly under another sun before drifting once more into the dark, carrying their light with them. As 3I Atlas drew closer to the Sun, the excitement among astronomers deepened. The comet's coma shimmered with life. But behind that light was a question far older than humanity itself. What is it made of? To answer that, scientists turned to one of the most powerful instruments ever built for seeing the unseen, the James Webb Space Telescope. Suspended far from Earth, beyond the haze of its atmosphere, Webb's golden mirrors could look into wavelengths of light, invisible to the human eye. In the realm of infrared, heat itself becomes language, and every molecule speaks in its own distinct tone. It was here, in these subtle frequencies, that the chemical secrets of 3I Atlas would be heard. Unlike visible light, infrared radiation carries the fingerprints of composition. Each type of gas absorbs and emits energy in a unique pattern, leaving a spectral code that tells scientists what elements are present and in what quantities. As Webb's instruments focused on the comet's glowing envelope, they collected that code line by line. The data that streamed back to Earth looked abstract, jagged graphs of intensity and wavelength. But to those trained to read them, they were poetry. Peaks and valleys became syllables. The light itself became a story. The first results were both familiar and surprising. As expected, water vapor dominated much of the spectrum. Wherever sunlight warms an icy nucleus, water is among the first compounds to sublimate. Alongside it appeared clear signatures of carbon monoxide and carbon dioxide, the volatile ices that vaporize more easily than water. But as the analysis continued, a curious imbalance emerged. The lines for carbon dioxide were stronger, much stronger than those seen in comets born of our own Sunday. It was as if 3I Atlas had been sculpted in a colder, deeper region of space, a nursery where carbon-based ices could freeze in abundance before being locked away for billions of years. This discovery rippled through the astronomical community. In our solar system, comets typically contain more water than carbon dioxide, reflecting the moderate temperatures that prevailed when the planets formed. But the ratio within 3I Atlas reversed that expectation. Here was a comet whose chemistry carried the signature of a distant star's birth zone, one colder and farther from its light than the Sun's comets had ever known. The inference was profound. Other planetary systems are not merely versions of ours. They have their own chemical personalities, shaped by the distances, densities, and temperatures of their creation. Scientists describe this difference as finding a new dialect in a cosmic language. The basic elements, oxygen, carbon, hydrogen, were the same everywhere, but their proportions told of different histories. The high abundance of carbon dioxide suggested that the nebula surrounding Atlas's original star had cooled quickly and remained cold for long enough to preserve that volatile ice. Its presence hinted at a world-forming region rich in carbon compounds, perhaps where planets would emerge with thicker atmospheres or darker surfaces than Earth. Every molecule escaping from the comet was a messenger, whispering of a sun that once shone on worlds we will never see. The James Webb Space Telescope also detected smaller traces of methanol, ammonia, and complex organic molecules, all drifting outward in the faint vapor of the coma. Such compounds are the building blocks of life as we know it, though here they existed only as chemistry, not biology. Still, their presence deepened the sense of kinship between our system and others. Life or no life, the ingredients are shared. The recipe is universal, even if every kitchen in the galaxy seasons it differently. When researchers compared Atlas's spectra with that of 2I Borisov, the interstellar comet discovered in 2019, the contrast became even more striking. Borisov had resembled our local comets closely. Its water and carbon dioxide ratios fell within familiar bounds, its activity predictable. 3I Atlas, however, told another story. It was richer in carbon dioxide, poorer in water, and contained subtle variations in the patterns of dust emission that implied differences in grain size and mineral content. Together, These two visitors proved what theory had long suggested, that the galaxy's comets are as varied as its stars. No single model can describe them all. Diversity is not an exception in the cosmos, it is its rule. To many scientists, this realization carried a quiet emotional weight. For generations, astronomers have studied the heavens with a mix of humility and curiosity, seeking both the familiar and the alien. Here, within a small, glowing wanderer, was both. 3I Atlas followed the same physical laws that guide every comet: ice vaporizing under heat, dust scattering sunlight. But the details of its composition were unmistakably foreign. The spectrum was not just data, it was identity. It said, "I was born elsewhere. I carry the memory of another world's dawn." Interpreting that message required care. The light, captured by Webb, traveled across millions of kilometers, passing through instruments cooled to near absolute zero to prevent their own heat from drowning out the faint signals. Each observation demanded hours of calibration and subtraction, removing the glow of the telescope itself, the background of zodiacal light, the interference of cosmic radiation. Only after this long cleansing could the pure voice of the comet be heard, and when it finally was, the conclusion stood firm. 3I Atlas was chemically distinct from anything that had ever visited us before. Beyond its specific molecules, the comet offered a new kind of evidence, direct proof that planetary systems across the galaxy form under widely varying conditions. Each one leaves a different chemical signature in the comets it creates. To find such diversity within just 3 known interstellar visitors was astonishing. It meant that the galaxy's history of planet formation is not uniform. It is an intricate mosaic of environments, each producing its own kind of frozen archive. For astrophysicists, this insight reframed the idea of cosmic sampling. Every interstellar comet that enters our system is more than an object of curiosity. It is a piece of another solar system's record, preserved in ice and released into light when it approaches our Sunday. Studying these visitors is like reading fragments of ancient letters sent from across the Milky Way. The message is written in chemistry, and each atom is a word. Water speaks of temperature, carbon dioxide of distance, carbon monoxide of density. Together, they form sentences describing how other worlds once came to be. The implications reached beyond pure science. In the measured spectra, some astronomers saw a kind of kinship that transcended space. The same molecules that built our oceans, our air, and even our bodies also drift in the tails of comets born under different stars. The carbon that burns in our fires and the oxygen we breathe are not unique. They are part of a galactic language of matter. To see that universality reflected in a single wandering fragment was both humbling and uplifting. Discussions soon turned to the origin of Atlas's parent star. Based on its velocity and orbit through the Milky Way, some researchers proposed that it might have come from the galaxy's thick disk, an older, quieter population of stars formed in the early days of the Milky Way. Such stars are typically lower in heavy elements, their planets and comets richer in carbon compounds and poorer in silicates. If Atlas indeed hailed from such a region, its chemistry would make perfect sense, a fossil of an ancient, cooler environment. In this interpretation, the comet was not merely interstellar, it was intergenerational, older than our Sun itself. Through all this analysis, the tone of discovery remained serene. There were no shouts or celebrations, only the quiet rhythm of data being interpreted, graphs being refined, hypotheses compared. The wonder lay not in surprise, but in clarity. For once, the galaxy had spoken plainly. It told us that there are countless recipes for making worlds, countless ways that starlight and dust can combine into planets and seas, and perhaps, somewhere, into life. The James Webb Space Telescope continued its watch as the comet rounded the Sunday. Over weeks, the spectra evolved subtly, showing changes in the relative strength of molecular lines as sunlight peeled away different layers of material. This dynamic chemistry revealed not only what the comet contained, but how it released it, how ancient ices cracked and vented, how dust grains clustered and drifted. In those patterns, scientists could infer the structure of the nucleus itself, denser at the core, more porous near the surface, bound together by time and cold rather than gravity. By the end of its observation campaign, Webb had provided something unprecedented: the first full chemical profile of an interstellar comet under solar heating. The data confirmed that Atlas's ices were rich in carbon dioxide, moderate in carbon monoxide, and laced with faint signatures of organic complexity. Comparing these results with the solar system's comets revealed just how flexible nature can be in building the same forms from different materials. In the language of science, these findings expanded the sample size of known interstellar chemistry. In the language of wonder, they deepened our sense of belonging in a universe that is both varied and connected. To understand the materials of another world is to glimpse its star's character, to feel for a moment that we stand within a living galaxy whose every corner hums with its own variation on a shared theme. Each molecule released from 3I Atlas was more than a particle, it was a letter in a cosmic alphabet. Together they wrote sentences about temperature, distance, and time. They described a star we will never see, and planets that may never form, but also reminded us that we, too, are products of chemistry written in light. The comet's spectrum was a story told slowly, not in sound but in color, across the emptiness between stars. When astronomers looked at the final graphs, they saw more than data, they saw narrative. The peaks and troughs of the spectrum became punctuation in a tale of creation and endurance. Within those patterns lay the simple truth that matter remembers. Ices remember the temperature at which they froze. Dust remembers the stars that forged it. Light remembers the journey it took to reach us. And through that memory, 3I Atlas allowed us to read a single page of a book written across the galaxy. A page that began long before our sun was born and continues, even now, as its faint particles drift back into the dark. In this way, chemistry became history, and light became voice. The discovery of 3I Atlas did more than enrich our catalogues of data. It reminded us that the universe itself is alive, with stories waiting to be translated. Each time a comet from another star enters our skies, it offers us a sentence in that infinite narrative. This one, luminous and serene, said simply, "I carry the memory of another world, and in my passing, I let you remember too." In the months after its discovery, as the data deepened and the comet's light began to fade, astronomers turned from observation to reflection. They had learned what 3I Atlas was made of, how it moved, and how it breathed under the sun's touch. But a final question remained the oldest one. Where did it come from? To answer it, they traced its path backward through space, using gravity itself as their guide. Every orbit, every deflection, every glancing encounter left a mathematical echo that could, if followed carefully enough, reveal its origin. Yet the further they projected the orbit into the past, the more uncertain the trail became. Stars move, the galaxy turns, and over billions of years, the cosmic landscape changes beyond recognition. Still, in the broad sweep of its motion, a clue emerged: the velocity of 3I Atlas, its direction of entry, and its tilt relative to the galactic plane, suggested that it did not come from the thin disk where our sun and most of the bright, young stars reside. Instead, its motion aligned with the thick disk, an older, quieter layer of the Milky Way that extends above and below the glittering spiral arms. The thick disk is a kind of fossil stratum of the galaxy, home to ancient stars that formed in the Milky Way's youth, long before the sun was born. If Atlas indeed belonged to this population, then it was a messenger from a time more distant than any record on Earth, carrying the chemistry and silence of an era when the galaxy itself was still shaping its first generations of stars. To picture the thick disk is to imagine a vast, diffuse halo of light surrounding the thin, shining band of the Milky Way. Its stars are dimmer, older, and poorer in heavy elements. Their light carries a reddish tint, not from dust, but from age, the cool glow of suns that have burned steadily for 10 or 12 billion years. Around those ancient stars, the early ingredients of planetary systems once swirled: hydrogen, helium, carbon, and oxygen, mixed with traces of metals forged by the first supernovae. In those primitive disks, countless small bodies formed icy fragments and rocky seeds. Some grew into planets, others remained wanderers. Among them, perhaps, was the one that would one day be called 3I Atlas. Its life likely began as part of a distant solar system, orbiting far from its parent star, in the frozen reaches where sunlight was a rumor more than a force. There, beyond the gravitational grasp of the inner planets, the object slept in cold shadow. But planetary systems are restless places. As giant planets coalesced and migrated, their gravity disturbed the outer debris, flinging comets into new paths. Some were cast inward toward their suns, others outward into the void. The most powerful encounters acted like cosmic slingshots, imparting enough speed for escape. One such meeting, perhaps with a world the size of Jupiter or larger, sent Atlas hurtling beyond its home star's reach. In that instant, it ceased to belong to any system. Its journey as an interstellar traveler had begun. From that moment, time changed meaning. Without a sun to orbit, Atlas moved freely through the galaxy, guided only by inertia and the faint pulls of passing stars. For billions of years longer than life has existed on Earth, it drifted through the cold between suns. Space in those regions is not empty, but very close to it. A handful of atoms per cubic centimeter, enough to whisper against the comet's surface, but never to erode it. Temperatures hover near absolute zero, freezing the ices into a hardness stronger than stone. In such conditions, change slows to nearly nothing. The comet became a capsule, preserving within it the chemistry and structure of its birth. Now and then, its path might have carried it through a diffuse cloud of gas or the outskirts of a stellar cluster. Occasionally, a nearby star's gravity would tug at its course, altering its velocity by a fraction of a percent. Over the ages, those small deflections accumulated, bending its trajectory gradually toward the inner regions of the Milky Way. Yet, despite these encounters, Atlas endured unaltered, a relic adrift in the galaxy's long memory. When at last it approached the domain of our Sun, it did so not as a visitor seeking warmth, but as a survivor of time itself. To astronomers tracing its orbit, this endurance was astonishing. Comets within our solar system are fragile, their surfaces reshaped each time they circle the Sunday. But 3I Atlas showed little evidence of such history. Its outer layers were pristine, its chemistry untouched by repeated heating and cooling cycles. It was as though it had been frozen since the dawn of its creation, its molecular composition still echoing the environment of an ancient star's nursery. That purity made it invaluable. To study it was to peer backward into epochs that no telescope could ever witness directly. If the comet's trajectory did indeed link it to the thick disk, then it was older than the Sun by billions of years. Our star is about 4.5 billion years old. The thick disk's oldest stars date to more than twice that age. Atlas, forged in their company, might have formed when the Milky Way was still young, when galaxies collided more often, when the central bulge was swelling with new light, and when the elements that make up life were only beginning to circulate. In this sense, 3I Atlas was not just interstellar, but intergenerational. It belonged to a cosmic era before ours, a chapter of the galaxy's autobiography written long before Earth's story began. The idea that it might predate our Sun carried profound implications. It meant that the materials now glowing in its tail, carbon, oxygen, water ice, were older than the solar system, older than the planets, older even than the atoms within our own bodies. It meant that when sunlight touched it and released its gases into space, those molecules were shining under our star for the very first time. In that meeting of ancient matter and modern light, time folded upon itself. The past and the present shared the same breath. And yet, despite all the data and all the mathematics, the comet's precise birthplace will almost certainly remain unknown. The Milky Way is too dynamic, too vast, its stars weaving through one another like dancers in slow motion. Over billions of years, the gravitational tugs from countless encounters erase the fingerprints of origin. A single close pass near another star can alter a comet's path enough to make backtracking impossible. In the case of Atlas, the journey has been long enough, and the deflections many enough, that its home star is now lost among hundreds of millions. We can trace the general region of its ancestry, but not the address. Some might find this anonymity frustrating. Others find it poetic. To be untraceable is also to be universal. Atlas is not the child of any one system. It is the product of the galaxy itself. Its atoms have mingled with the dust of supernovae, its ices condensed from clouds, enriched by generations of dying stars. In its silence, it carries the memory of those cycles of creation and destruction that shape all matter. Every element in its body, hydrogen from the Big Bang, oxygen from ancient stellar furnaces, carbon from the ashes of giants, has traveled through time to form this single, wandering monument to continuity. The comet's long solitude also preserved its simplicity. Over eons, it passed through regions of thin gas and starlight, but nothing dense enough to erode it. Occasionally, cosmic rays struck its surface, embedding microscopic scars that now serve as records of interstellar radiation. Those impacts aged its exterior by degrees, darkening it slightly. But beneath that thin crust, the ice remained pure. In this way, Atlas became not merely an interstellar traveler, but a cosmic archive, carrying within it data about the environment between stars, information about magnetic fields, cosmic ray flux, and dust composition from epochs when the galaxy was still young. To the scientists studying it, the comet's age and isolation gave it a kind of dignity. They spoke of it as a witness, one that had seen the galaxy evolve from turbulence to order. Its motion through space is serene now, but it was likely born in violence. The gravitational slingshot that cast it away, the collisions and migrations of planets around its parent star, the energy that transformed a stable orbit into a path of exile. That act of ejection, though destructive, became a gift. Without it, the comet would have remained invisible forever, circling a star we could never reach. By losing its home, Atlas found us. In tracing its history, astronomers often imagined its long crossing. Billions of years spent drifting through darkness, passing unseen by generations of stars. Occasionally, it might have skirted the edge of a nebula, its surface faintly illuminated by the distant glow of newborn suns. Perhaps it passed near the spiral arms of the galaxy, watching from afar as waves of star formation rippled outward. Through it all, it endured, changing only slightly with each encounter, until at last our sun's gravity reached out and pulled it into a brief dance. This encounter, brief as it may be, has allowed us to hold a conversation with the ancient galaxy itself. When sunlight warmed its surface and instruments recorded the vapors it released, we were, in effect, reading the oldest chapter of our shared history. 3I Atlas is not a comet of our time, yet its visit bridges the gulf between eras. It reminds us that the Milky Way is not a static collection of stars, but a living organism of motion and exchange. Systems lose and gain material constantly. The galaxy recycles itself through travelers like this one. In the end, perhaps it does not matter which star once held Atlas in its grasp. What matters is that it carries the essence of many stars, the blended heritage of a galaxy in motion. It is, as one astronomer poetically described, a messenger without an address, a fragment of history adrift, representing not one origin but all of them. When we look at it, we see not a stranger, but a member of the same family that built our own world. It teaches us that the galaxy's story is one of continuity through change, of unity through distance. Soon, 3I Atlas will fade beyond the range of our telescopes, returning to the silence from which it came. But the knowledge it leaves behind will stay a map of chemistry, motion, and time that links our sun to the oldest stars of the Milky Way. Its path, carved in numbers and light, will remain a gentle reminder that even the most solitary travelers belong somewhere. And if the galaxy could speak, it might say of this small, enduring wanderer, it has no home, because it is home itself, the quiet representative of us all, drifting through eternity beneath the shared glow of countless suns. When 3I Atlas was confirmed as an interstellar comet, the discovery did not belong to one person or one observatory. It became the shared work of a planet. Within hours of its first announcement, observatories around the world began adjusting schedules, shifting instruments, and coordinating exposure windows as if passing a relay baton around the globe. As the Earth turned, the night sky moved from one continent to another, and with it, the faint light of the comet. In Hawaii, Chile, Spain, and South Africa, domes opened in sequence. When dawn ended observations in one hemisphere, dusk welcomed them in another. The comet never left human sight. It simply changed guardians as the planet spun beneath it. This rhythm of cooperation became one of the quiet triumphs of modern astronomy. A choreography of light, data, and patience performed by thousands of unseen hands. At the heart of this collaboration stood the Minor Planet Center, a small yet indispensable hub based at the Smithsonian Astrophysical Observatory. Every fragment of data, every positional measurement, every brightness estimate, every spectrum from ground or orbit flowed first to this center. There, algorithms and experts merged the observations into a unified record, filtering duplicates, correcting coordinates, and refining the orbit in real time. Within hours, new predictions were released back to the community, so that telescopes everywhere could aim precisely. This cycle repeated day after day, a pulse of information beating steadily as the comet approached the Sunday. The Minor Planet Center acted as the galaxy's switchboard on Earth, turning millions of independent observations into a single coherent story. Above the atmosphere, the Hubble Space Telescope continued its watch, adding a perspective no ground instrument could match. Its long, stable exposures captured the fine details of the coma, the delicate jets that fanned from the nucleus, the subtle changes in the structure of the tail, the tiny flickers in brightness that marked the comet's slow rotation. From orbit, Hubble could see the comet as a living system, not just a point of light. Its images became reference frames for all other observers, allowing teams on the ground to compare and calibrate their data. In this way, Hubble was both a witness and a mentor, a bridge between space-based precision and Earth-bound curiosity. Each night, new data sets appeared in public archives, free for anyone to analyze. The spirit of this research was not secrecy, but openness. Professional astronomers shared raw images within hours, inviting others to check, to measure, to contribute. Amateur astronomers, armed with smaller telescopes, but enormous enthusiasm, joined the effort, recording long-exposure images from backyards and mountain plateaus. Many of their measurements of brightness and tail length became part of the official record. In the 21st century sky, the line between professional and amateur blurred beautifully. The night belonged to all who looked upward with care. Across universities, teams of graduate students found themselves drawn into the work. Some processed raw spectra, identifying the fingerprints of gases. Others modeled the dynamics of the dust tail or built software to track the comet's position. For many of them, 3I Atlas was the first major discovery of their careers, a chance to participate in something global, something larger than any classroom or laboratory. They traded data through online channels, joined virtual meetings across time zones, and worked through nights lit only by monitor glow and starlight. The comet, silent and indifferent, became a teacher. It showed them that science is not only about knowledge, but about connection. The subtle network of minds focused on one fragile point of light. In this cooperative web, every observatory was a node, and every researcher a link. The European Southern Observatory provided high-resolution spectroscopy. Mauna Kea's instruments mapped the distribution of dust. Smaller facilities monitored brightness fluctuations to detect outbursts. Together, they created a continuous chain of observation from the infrared through visible light to ultraviolet, capturing the comet's behavior in full spectrum. The result was not just data but music, a symphony of wavelengths resonating through the shared language of collaboration. While 3I Atlas was the immediate focus, its discovery also sharpened the world's attention on the Vera Rubin Observatory, then preparing for full operation in Chile. Designed to scan the entire visible sky every few nights, Rubin's immense camera will generate more images than any telescope before it. When it begins, it will likely detect interstellar visitors like Atlas years before they approach the Sun, providing the time needed to plan spacecraft encounters. To many, this upcoming observatory represents the next movement in the song that Atlas began, the promise of earlier warnings, deeper understanding, and perhaps one day, direct contact. The excitement surrounding Rubin was tangible. Scientists could already imagine its vast archive of transient phenomena, each a potential story waiting to be discovered. In earlier eras, discoveries like this might have taken months to circulate. Now, data traveled at the speed of light through fiber optics. When a telescope in Spain recorded a new observation, it appeared almost instantly on monitors in Arizona, Tokyo, and Cape Town. Software automatically cross-checked the results, updated orbital paths, and sent alerts to all subscribers. The collaboration was not a hierarchy, but a living network, decentralized, democratic, and astonishingly fast. It reflected the new era of open science, where information is not hoarded but shared, and where progress accelerates through collective effort. Amid the precision and computation, there was still wonder. Astronomers spoke often of the strange intimacy of global collaboration. Thousands of people, many of whom would never meet, all united by a single, moving speck. In the quiet hours before dawn, when data streams slowed and instruments hummed softly, some researchers would step outside observatory domes to look with their own eyes at the region of sky that contained Atlas. Most could not see it directly, but knowing that somewhere in that darkness, their instruments were following a traveler from another star was enough to fill them with quiet awe. They were part of a moment in human history that few generations experience, a time when knowledge crosses both horizons and borders freely. The cooperation extended beyond professional boundaries. News outlets, educators, and science communicators translated the ongoing findings for the public. Online viewers followed live updates, animated trajectories, and digital renderings. Artists painted the comet's imagined appearance, musicians composed pieces inspired by its path, and children in classrooms drew pictures of glowing tails and endless space. Science, in its best form, became culture, a meeting place for imagination and evidence. The shared curiosity that began in laboratories spread outward into the collective consciousness of the world. In this global effort, the comet served as a kind of mirror, reflecting not only the light of the sun but the character of humanity. We are a species that looks outward together. Though nations, languages, and disciplines differ, the night sky belongs to all of us. Atlas reminded the world that discovery is not a competition but a chorus. Every observation, whether from a mountain observatory or a backyard telescope, was a note in that harmony. The grandeur of the cosmos can seem solitary, but in studying it, we are never alone. As the months passed, the rhythm of observation continued, a heartbeat of light recorded, shared, and interpreted. Minor updates arrived daily from the coordination center. New graphs, new fits, new predictions. Each one refined the comet's story. When an outburst briefly brightened the coma, within minutes, the news raced around the planet. Observatories re-aimed their optics, amateurs recalibrated, and the next wave of images flowed in. This synchronization, once impossible, now unfolded seamlessly, an orchestra responding instantly to a single cosmic cue. Behind the scenes, the technology enabling this coordination evolved as quietly as the comet itself. Machine learning tools filtered raw data to identify anomalies. Automated pipelines flagged interesting changes. Citizen science platforms allowed volunteers to classify images and confirm detections. The boundaries between expert and enthusiast